So okay, today we are going to learn how to find the majority element which is greater than n by 2 times, which is greater than n by 2 times. So let us try to know what is which is greater than n by 2 times. Okay, uh, I'd say so. We should need to return the element that appears uh, more than n by 2 times. What does that means? So here we have given an array. So my bad. See here we have given an array. Here two, as you observe, two appears once, twice, thrice, four. Here the two appears four times, right? Here the two appears four times. Then what is n by two? N by two times. What is exactly that means? Let's try it. I say we have given an array of size 0, 1, 2, 3, 4, 5, 6, 7. Right? We have given an array of size 7, and I say which is greater than n by 2 times. So what does that mean? 7 by 2. So 7 by 2, which is 3, right? 7 by 2, which is 3. And we should need to return we should need to return that majority element, which gives uh, this two element is giving us 4, right? This two element is giving us 4. So here 3 is, here 4 is greater than 3. That's why we should need to return the element as majority element, that is 4. We should need to return the element 2, because here it is greater than n by 2 times. Here's the 4 is greater than n by 2 times. Greater than n by 2 times, right? That is 3 exactly. So how are we going to do this? So here the 2 appears more than 4 times, and it is, let me explain this. Here the 2 appears 4 times, which is greater than n by 2 times, that is 3, which is 4 is greater than 3. So I'm going to return this element that is 2. Return this element that is 2, right? I'm going to return the element that is 2. So how we can do this? I'll just code this thing and show you. So this is a brute force solution. As we all know that this is the brute force solution. Let's start from the brute force solution. What I'm going to do here is I'll do this thing. I'll write a loop which is I equals 0, I is less than n, I plus plus. Here what I'm going to do is I'll add a counter. What I'm going to do is every time that I visit an element and check how many times that is repeated. For that I'll add a counter. If I was at the element, if I was at the element 2, then I'll go to another element 2 and I check, okay, this is one time, this is one time, this is second time, this is third time, this is third time, this is fourth time. Then I'll increase the counter by 1 and I go to 2. It's like I go to 1, then I increase the counter by 1. Then I'll go to 2, another 2. Then and I increase the counter by 2. Then I go to another 2. And then I increase the counter by 2. A counter by 3. Then I go to another 2. And then I increase the counter by 4. So here I found this maximum majority element. So this is how its counter is going to help us. So I say initially the counter here will be 0. So counter is 0. I'll add another loop that is j equals 0. So it is 0 indexing. And my I pointer will be here. My I pointer will be here. And my j pointer will be here. First I check if my I pointer is 2. If my I pointer is 2, I'll iterate through the array using j. I'll iterate to the array using j, and I increase the counter to 1 if I repeated one time, and I move and I see 2 again, then I increase the counter to 2, then I increase the counter to 3, then I increase the counter to 4, and this is how I found the count majority element. We write another condition. We write this at first. I say if array of I is equal to array of j, then counter should increment. That means if the if this is array of I and this is array of j, is both the same, then I increase the counter. And this is same, then I increase the counter. This is same, then I increase the counter. And once you've done this, then I say, and I write another condition. That is if the counter that we get is greater than n by 2 times, then I say, then I'll return that element, that array element. Then I return that array element. Otherwise, I say I'll return -1 if I don't find that element. If there is no element that exists in the array which is not greater than n by 2 times. Okay, this is how the brute force solution was used to work, and I hope you guys understand this. So let me say what happens here, and I'll explain. So at first I was at the I element, and I say I'll check for 2. I'll check for 2. I check for 2. I check for 2. Then when I was here at the I pointer, then I say j is iterating through the array. Then j is increasing the counter. Okay, I find 2. If the array of I is equal to array of j, then I increase the counter. If the array of I is equal to array of j, then I increase the counter. This is not equal. This is not equal. This is not equal. Then I increase this array of I is equal to array of j. Then I increase the counter. Then I increase the counter. So this is how it works. And at the end, it is used to return the maximum majority element that will be greater than n by 2 times of the given array. Hope you guys find this. So at last it's like 2 is the majority element that is repeating for 4 times, and it is greater than n by 2 times as well. That is 3, right? So 4 is greater than 3. So this is a brute force solution. Let us try to optimize the time complexity. Let us try to find the time complexity. Sorry. Here we have got the 2 loops, and they will be running for the n cube times, n square. Here the n square, right? So this is the time complexity. The time complexity is big O of n square, right? So today we are going to find the better solution for the majority element. So let us try to understand how can we do the better solution. I say we are going to do the better solution using hashing. So I'm going to do this using hashing. And how I'm going to do this? I'll take a hash map first. I'll take a hash map. This is an unordered map. Well, what it contains? It contains the element and the counter. And it contains the element in the counter. What I'm going to do is I'll going to iterate the array, and I take 2, and I say 2 you have occurred 1 time. Right now 2 has occurred 1 time. Then I'm going to put this into the hash map. The element here is 2, and I say it occurs 1 time. Right? Okay. Then I move, and again 2 it appears twice, second time. Okay, done. Then I move, I say 1 occurs 1 time. I say element 1 occurs 1 time. And I move, I say 3 occurs 1 time. 3 occurs once. And I move, 3 occurs twice. You see, 3 occurs twice. I'll erase this. 3 occurs twice. Then I move, 2 occurs third time. 3. Now I move, 2 occurs 4 times. 2 occurs 4 times. 2 occurs 4 times. 2 occurs 4 times. Once I have completed the iteration over the array, and what I'm going to do is, what I'm going to do here is, I'll traverse over the map. Once I have come here, I'll check the majority element 2 is repeating 4 times. The majority element 2, which is repeating for the 4 times. And this is my answer. This is my answer. So which is kind of, we say here 2, the majority element that is repeating for 4 times, and which is greater than n by 2 times, that is 3, because size of the array here is 7, and here 4 is greater than 3. So this 2 is my majority element. So let us try to analyze the time complexity quickly. I say time complexity is big O of n logarithmic of n, because we're using an ordered map. What if we use an unordered map? If we use an unordered map, the time complexity will be like big O of n and plus big O of n, because we are traversing over the map. Because we are traversing over the map, right? Once we have completed that iteration over the array, and then again we are traversing over the map. For that, the time complexity will be like this, big O of n log n plus big O of n. And what about the space complexity? Space complexity will be obviously big O of n, because we are storing everything into the hash map, and big O of n is for, I say, if the array contains all the unique elements, all unique elements, then the hash map need to store these all unique elements. For that, the time complexity is big O of n. So this is the better solution for finding the majority element, which is greater than n by 2 times. So today we are going to find the majority element using the optimal solution. So today we are going to discuss the optimal solution. Right, okay, optimal solution, how we can achieve the optimal solution. So I'm going to use an algorithm called Morris. So I'm going to use an algorithm called Morris voting algorithm. Right. So we're going to achieve this using Morris voting algorithm. So let us try to start this. So okay, Morris voting algorithm consists of 2 variables. Remember, Morris voting algorithm consists of 2 variables, that is element and the counter. And here the counter is initialized with 0 and element is not yet initialized. Okay. So let us try to start this. I say if I was here, let's start iterating from the array. I was here at the 7, element 7. I say element 7. Okay, remember this element 7 is my hypothetical answer. I imagine element 7 is my majority element. So I'm going to say element 7 is my majority element. And I say when I was here, and I say element 7 is my majority element, then I increase the counter by 1. Then I move, and I have got 7 next time. So this is my majority element, that's why I increase the counter. That will be 2. Then I move. Here I have got 5. Here I've got 5. This is not my majority element. This is not my majority element. What I'm going to do? I'll decrease the counter by 1. Then it will become 1. 2 minus 1, 1, right? Then I move. This is element 7 is my majority element. So I'll increase the counter by 1. I'll increase the counter by 1. Then now that this become 2. And I move. 5 is not my majority element. What I'm gonna do? I'll decrease the counter. Then it'll be like 1. And I go to 1. And I'll move 1. 1 is not my majority element. What I'm gonna do? I'll reduce the counter. Now the counter has become 0. Wow, nice. So up to here, what we have done here is, up to here, Up to here, what we have, that is, up to here, the majority element is 7. Majority elements 7 has incremented has incremented 1, 2, 3. Three times the majority elements has incremented for three times. For three times. Then what about these other elements? The other elements were 5 and 1, right? 5 and 1. 5 comma 1. Other elements. I say other elements. Then what happens here? These elements are also decremented. These elements are decremented. What happens here is these elements are decremented three times. These element has decremented three times, right? These elements are decremented three times. So I'm going to cancel this. I'm not going to take this majority element as 7. I'm going to cancel this. Okay. Yeah. Okay. I'll quickly erase this. Okay. Yes. Okay. I hope you get this. I'll erase this also now. So I'm not going to take my majority element now. We have cancelled 7, right? Okay. Now the counter is 0. Then I move to next another element. Then I move to the other element. Now my majority element will be 5. I take 5 as my majority element now. Then I increase the counter by 1. And I move. This is not my majority element. My majority element was 5. So I'll decrease the counter by 0. Oh my god. What happens here? Here it is incremented one time and it is decremented one time. Wow, nice. Okay, what I'm going to do here? Again, the counter has become 0. Then I don't take 7. Then I don't take 5 as my majority element now. Then I move. I've got the same 5, right? And I take 5 this as my majority element. And I increase the counter by 1. Then I move. So yes, this is my majority element 5. Then I increase the counter by 1. That is 2. Then I move. No, this is 7 is not my majority element. My majority element was 6. It was 5. So I didn't take 7. I'll decrement the counter. That is 1. Then I move. And then I've got the element 5. So it is my majority element. So I increment the counter to 2. Then I move. This is my majority element. Then I increment the counter to 3. Then I move. I've got 5 as again. So this is my majority element. I'm going to increment the counter by 4. So then I move. Then I have got the 5 element, which is my majority element. So I'm going to increment the counter by 1. Then I have the count. Then I got my majority element 5. So here I have got the majority element that is 5, which is counted for 5 times, right? Okay. So let's try to analyze what is the size of this array. The size of the array was 16. The size of the array was 16. Okay, I say 16 by 2. 16 by 2 is 8 times. Then how many times this majority element 5 has repeated? Let's try to count this. Okay. 1 time, 2 time, 3 time, 4, 5, 5, 6, 7, 8, and 9. 9 times. This majority element 5 was repeated 9 times. The element 5 has repeated 9 times, which is greater than n by 2 times. N by 2 times was 8, which is greater than 8. 9 is greater than 8. So my element 5 is my majority element. I say 5 is my majority element. So this is how we are going to find the Morris voting algorithm. How we are going to find the majority element using Morris voting algorithm? So the main thing in here is the Morris voting algorithm works on two variables, that is element and the counter. So just try to remember is whenever the majority element appears, increase the counter. increase the counter by 1. Increase the counter whenever the majority element appears, and increase the counter apart other element appears. Apart from that, other element appears, then decrease the counter. Then decrease the counter. Then decrease the counter. Okay, this is how the Morris voting algorithm was used to work. So this is the optimal solution. Let us try to analyze the time complexity here. So the time complexity, let's say here the time complexity is big O of n. And I say big O of plus big O of n. Why this plus big O of n? Because if when you're verifying the array, and you have not find majority element, then the time complexity will be big of n. Right? If you don't find the majority element, then the time complexity will be big of n, and whatever the space complexity is obviously big of 1, because we are not using any kind of extra space. This is the time complexity and the space complexity. So in Morris algorithm, what we have done here is step one we have done here is we say I say apply the Morris algorithm. First apply the Morris voting algorithm, Morris voting algo, and at step 2 we verify the array. We verify the array element which appears, which is majority or not, we're just going to verify that as well. And here what we're going to do here is, in the last step, we say, and I say iterate the array. And iterate the array and find how many times, and try to find how many times the majority element appears, and if it is greater than n by 2 times, then it is my majority element. Then it is my majority element. So this is how Morris voting algorithm is used to work for the optimal solution.